Welcome to question 5 of the 2019 Mathematical Methods Exam 1 for the Northern Hemisphere. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. For question 5 we're told that h is a function with a domain of negative 3/2 to infinity, where h of x has a rule square root of 2x plus 3 subtract 2. For part A, we're asked to find the value or values of x such that h of x squared equals 1. So if h of x squared equals 1, we can square root both sides of this and reveal that h of x must equal plus or minus 1. So we'll now consider each of those cases one at a time to answer this problem. So the first one we're going to consider is when h of x is equal to negative 1. So therefore we find that our rule, which is the square root of 2x plus 3 minus 2 must equal negative 1. Now we can add the 2 to both sides, which means the square root of 2x plus 3 must actually equal 1. So we need the square root of some number to equal 1. So therefore, if we square both sides, we can find out what that number needs to be. So we would have 2x plus 3 on the left-hand side, and 1 squared is still 1. So we just require 2x plus 3 to equal 1. Next we can subtract 2 from both sides, so we find that 2x must equal negative 2, and therefore x must equal negative 1 as a possible solution to this equation. So the last thing we need to do just before ticking off that as one of our answers is check that x equals negative 1 is inside the domain. So having a look up here, we can see the domain goes from negative 3 on 2, which is negative 1.5, to infinity. So x equals negative 1 is an answer to this problem. Next, we'll consider the case where h of x is equal to positive 1. So therefore, our rule must be the square root of 2x plus 3 minus 2 is equal to 1. And then again we add 2, so that will give us the square root of 2x plus 3 must equal 3. Therefore, we're looking for some number that when we take the square root of it, it comes out to be 3. So squaring both sides, again like we did before, will reveal what that number needs to be. So on the left-hand side we'll have 2x plus 3 must equal, and 3 squared is 9. Next we can subtract the 3, so we get 2x is equal to 6. And dividing by 2 as our last step will give x is equal to 3. And double checking that domain, x equals 3 does fit inside, so that is a second value of x that satisfies this question. So both answers to part A are x equals negative 1 and x equals 3. And from the examiner's report we can see that the two answers to this question were indeed x equals negative 1 and x equals 3. And both of those values are inside the domain that was given. For part B, we still have the same function, and we're asked to find the domain and the rule for the inverse function. So to answer this question, the first thing that I'm going to want to do is we're just going to let y equal h of x, so that all we have is x and y in our rule. So therefore, if y equals h of x, we simply find that y is equal to the square root of 2x plus 3 minus 2. The second step is to swap x and y to find the inverse. And it's important in an exam to actually state that's what you're doing, that you are swapping x and y to find the inverse. So therefore our equation is now x equals the square root of 2y plus 3 minus 2. And you can see all we've done there is we've swapped x and y. Our third step is to solve for y. So to do that, I'm going to start by adding 2 to both sides of this equation. So we find that x plus 2 is equal to 2y plus 3, still under the square root sign. So next we want to square both sides so that we get 2y plus 3 by itself. So we're going to have x plus 2 all squared is equal to 2y plus 3. And then what we can do is we can subtract 3 and divide by 2. So I'll do these two steps together to find y by itself. And then notation wise, we need to actually express this as h inverse of x. So our fourth and final step is to state it as h inverse of x equals. And then we also need to state the domain of h inverse. So h inverse of x is going to equal, and we'd have x plus 2 all squared, and then we would also have minus 3, but we've divided by 2 to get rid of the coefficient of y, so it would be x plus 2 all squared over 2 minus 3 over 2. So that's part of our answer, and now the next thing we need to do is also work out the domain of that function. So personally for me, I think the best way to do that is actually to consider a sketch of the original function, because the range of the original is going to equal the domain of the inverse. So for this graph, we're going to consider the transformations that have occurred to it, and then we're going to get a brief sketch from there. So the square root of 2x plus 3 minus 2 means the graph's been moved down 2 units, or 2 units in the negative y direction, and this 2x plus 3 actually results in the graph being dilated from the y-axis by a half, as well as a translation of only negative 3 on 2 in the negative x direction. So that negative 3 on 2 there is also indicating what the end point of this graph would be at. So we'd have a point down here, and then our graph isn't reflected in any way, so it would just come up here, and that would be the basic shape. We know that this would be minus 3 on 2, and that the y value of that endpoint would be minus 2. So from there, we can now see what the range of the original is, which is going to be the domain of the inverse. So we have h inverse of x as rule just there, and then it's going to be for x is an element of, and it's going to be minus 2 included to infinity. And again, that's because this here is the range of the original, so the range of h is equal to the domain of h inverse. So therefore we now have the complete answer for this question. And if we just have a quick look at the examiner's report, which is essentially just the answers for this question, we can see that our rule for h inverse of x matched theirs, and that the range that we stated, which becomes the domain of the inverse, is correct.